today, everybody, we're doing, one second, Algebra 1 test review. These are questions that are going to be on the test tomorrow. Question 1. All right, here we go, everybody. Problem number 1, right here. What do you guys think I'm going to do first? Problem number 1. Distribute. So would you please go ahead and distribute all the way. Wherever you guys see something, distribute. That's what I want you to do. We're going to distribute. What are we going to distribute? We're going to distribute this 4, and we're also going to distribute this -3. Go ahead and do that. All right, here we go. 4 times x, what y'all get? 4 x's, right? 4 times -5, what you get? Now we're just going to drop down this 8x right here. Ooh, -3 times 2x. -6 and then an x. Very good. -3 times a +6. -18 is right. Very good. Excellent. So what was step number 1? What did we use? What property did we use, everybody? That's right. We used the distributive between R right there. Sorry. Oh, it's horrible R. Just pretend like I wrote a beautiful R. Distributive. There we go. Use distributive property. Now, step number 2, everybody, we're going to write combine something. Combine. Yeah, combine like terms. All right. So right now, I'm going to highlight our like terms in a totally different color range. Whatever that color shows up on the screen, that's what we do. So right now, I'm scanning. Are these terms alike? No, they're not, are they? Okay. Anything alike over here? Ooh, what? That's right, the 8x and the 6x. They're totally alike. And we're going to combine those to make. You had 8 x's and you got rid of 6 x's. Now, how many x's do you still have alive? 2 x's, that's right. 2 x's. All right. So now we have x's on both sides, all right? So step number 3, what I'm going to do is I need to isolate the variable, which means get all the letters out themselves. Isolate the variable. All right. So where am I going to move all of my x's? Not just x's, but where am I going to move it on the equation?
You didn't move all these x's.
I know all of his x's lived in Texas. I know. I'm just trying to say right now. All right. To the left. Yes. How do I get rid of this 2x? You could say, if you would have said you add a -2x, I would have totally agreed with you. But we're going to take away 2x, which means these are additive inverses, so that zeroes out. And we're going to take away a 2x, right? So 4x minus 2x is 2x. Bringing down the what? Bring down that minus 20 equals, we're bringing down the what? Bringing down that minus 18. So here we go. 2x, right? Minus 20 equals -18. What do I gotta do now? Not yet. You gotta get rid of that -20. So what am I gonna do to both sides? Add 20. I'm gonna put to both. Add 20 to both. I'm gonna add 20 to this side. I'm gonna add 20 to this side. You're almost done, thank God. What do I have on the left-hand side now? Yeah, where did I lose you? Go ahead. All right, how about this one? Did I lose you up here?
Yeah. Like, how did you get like 8x -6? I was trying to copy all this stuff.
Oh, okay. So here's how we got it. All right, the first step that we did was we used the distributive property. Okay.
Oh,
So
you combine like terms.
okay, here, yeah, this one I combine like terms. All right, and that's how I got the 2x. So it's 8x minus 6x. Okay. All right, and then all I did was bring down the -18, bring down the -20, combine those like terms. So right now, in this equation right here, I have a 2x, right? What does this cancel out to? 0, right? That's 0. So 0. What do I have over here? A +2. So all I have left is 2x equals 2. That's all I have left. Good. 2 times a number out there in the universe equals 2. Well, what number would have to be there? 1. Because 2 times 1 is 2. Now, yes, technically the last step is divide both sides by 2, and what is x equals a 1. Okay? X is always equal to s. All right? That's what it sees itself in the whole mirror. It says, hey, I'm an x. All right, now, everybody, this is what I want you guys to do now. You're like, man, there's no way I can remember all these steps. We have a graphing calculator. So, if you guys can do this, listen up. You're allowed to use this. I don't know why they let you, but apparently, the state of Texas is like, you know what? We're going to let them. So, this is y1. This is y2. I need you to type those in exactly as they appear in the graphing calculator. Right now, do it. 4 parentheses x minus 5. And the other one was 8x minus 3 open parentheses. X, was it plus 6? X plus,
No, 2x.
oh, 2x plus 6? All right, yeah, you got to type it in exactly as it appears. Can't do that. Not going to get it right. All right, so you guys got that? I'll give you a chance. Now, what did we find our answer to be? 1, right? X equals 1. So here's what you do. Hit the second in the window button. We're going to start our table at the number 1. And then we're going to hit second graph, which brings us to the table. Now, how do we know that number 1 is indeed the correct answer? Because they match. If they match, it's the answer. So what you could do technically is this. You go to your y equals, you type the equations in, and then you do what? You just check your table, and you, if you wanted to, you could scroll down to the number that you want. If you don't like to scroll down to that number, okay, what do you have to do? Hit second window, and you have to type that number in. You have to know how to get to this page, especially when you have a fraction. What if the answer was 3/4? And you have to start your table where? At 3/4. So you have to know. In your journal, you might want to write this down. Second window. That brings you to your table. I don't want you guys to raise your hand and say, hey, how do we get? Not the table, sorry. The table setup. Table setup. There we go. There we go. Table setup. I don't want you guys to raise your hand. Hey, how do you get to that table setup thing? What should you have done? Written those instructions down in your journal. Okay. All right. Now, we're moving down to number 2. All right. On this one, there's only one thing that you really have to worry about. You just have to combine like terms. You see that minus sign right here? You need to distribute that negative sign to both numbers. A plus sign you don't really have to worry about. So here's what you have. You have 2/3 x plus 1/5 y. When you distribute a negative sign to number 2, what's that going to become? That's right, negative 1/6 x, and a negative times a negative makes this a. This is where students would mess up. Okay. Now, if there's a plus sign, everything just stays the same. Okay. That's what I want you guys to write out. We're just organizing stuff. Okay. Next thing I'm going to do before I pause this video that you guys do is I'm going to highlight everything that I have that's alike. Now, if you don't have a highlighter, what could you do? You could box it in or circle it or something. Anything that's alike. X's can be added to other X's. Y's can be added to other Y's. That's why I was highlighting. Go to your calculator right now, everybody. We're going to type in. First number we're going to type in. We're going to type in 2 divided by 3 because there's 2/3 of X. Then what we're going to do is we're going to add a negative 1 divided by 6. All right? And what's the last one? 5/12. What we're going to do is we're going to add 5 divided by 12. Now notice I didn't put any x's next to this. Okay, well we can combine it. Yes. Did I down put 1/6? Yeah, negative 1/6. Here, I'll highlight it real quick. Okay. So my x's were in what? Let's see here. Blue. All right. So what was the first one? The first one was 2/3. What was the second one? Negative 1/6. What was the third one? 5/12. I'll go back. 5/12, negative 1/6, and 2/3. Okay? No. Don't. We're just adding like term. Press enter. You guys see that right there? Alright? Hey, hit the math button. Press enter twice, and look what you do. 11. That tells you right there, everybody. What is all of this? What is all of this combined to? 11/12. So what are we going to put right here? We're going to put 11/12. What? X. Look at that. See that part? So what we're going to do right now, boys and girls, we're going to scroll down and go, ooh. So far, guess what? That's 11/12. That's 11/12. So that's the stupid answer. We're not going to choose that one. All right. Now, you guys see the 1/5, the 3/4, and the 2y? We're going to do that next. All right. So here we go. 1/5 plus what? What's next? 3/4, right? 3 divided by 4 plus what? 2. Press enter, and it says 2.95. But what do I have to do? Math, enter, and bam, 59/20. So plus 59/20 what? Y. And oh my goodness gracious, that's not it. That's not it. This is totally it. All right. What was the only tricky part of this whole problem? Yeah. And what do we have to be able to do? You have to be able to. Yes. If you don't know which terms are alike, and you try to combine things that are not alike, you're going to get the wrong answer. But what does the calculator allow you to do? Does it allow you to be able to add fractions together? Yes. Okay. All right. Let's see here. Oops. So, moving on. Here we go. Number 3. It says the subtraction of two polynomials a and b is shown below. What does it say? It says a minus b equals c. All right. I'm going to zoom out just a little bit. Here we go. It says which expression represents which polynomial? Polynomial b. So we're going to try to find out what polynomial b is. If it says a minus b equals c, I want you guys to solve for b right now. Solve for b. I know what c is equal to. I want to know what b is equal to. All right? In order to solve for b, here's what I'm going to have to do. I'm going to have to take away an a from this side, and I'm going to have to take away an a from this side. What do you have left? Negative b equals what? C minus n a. But I don't want to know what a negative b is equal to. I want to know what a positive is. How can I go from a negative to a positive? Well, there's two different ways. Do what? Nope. You can either multiply everything by a negative or divide everything by a negative. So I'm just going to multiply. I'm going to take everything, I'm going to multiply every single number by a negative. What? Go back. Okay, so hold on. Let's just start over. Here we go. This says what? A minus b equals c. If we want to find out what b is equal to, so I gotta solve for b. Okay? So here's what I did. I had a minus b equals c. Now, there's two ways that you could do this. If you wanted, I started one way. If you wanted, I'll maybe do another way and see if it makes sense to you. Okay? You could also, if you wanted to, you could add a b to this side. And now what do you have? A equals what? C plus b. And then if you wanted to, you could take away a c from this side. And what is b equal to? B is equal to a minus c. Now what can I do? Now I can look over here. Do I know what a is equal to? Yes. Do I know what c is equal to? I do. So what do I have to do? I have to now take a, and what do I have to take away? I have to take away c. So here's what you would have to do. take A, which is what? 6n plus 2n minus 1. And you're going to take away all of C. What is C equal to? 14n plus 26n minus 31. Okay? Now, what I want you guys to do right now is write this down. Alright? And then I want you to distribute a negative to each of these. Okay? Distribute this negative to each of those numbers. Now, this is one way you can solve for B. Before we move on. Over here, there was one more thing I needed to do on this one. And I want you to see that it comes out to be the exact same thing. If you multiplied or divided everything by a negative, these become positive. This becomes a negative C, and that becomes a positive A. So B still will equal A minus C, just like we just had right over here. All right, B is equal to A minus C. Now, if we distribute this negative to all of them, what do you get? You get a negative 14n. You get a negative 26n, and then you get a positive 31. The negative times a negative is a positive. Now, everybody, this right here, there's only one thing we have to do left. We're just going to take everything and combine the like terms. So I'm going to combine all the terms that are alike. The m's are added together. The n's are added together. And these constants at the end are also added together. You have to organize those, okay? So what is 6n minus 14? Negative 8n. And what is 2 minus 26?
2 minus 24.
That's negative 24n. And what's negative 1 plus 31? What does that become? Positive 30. Okay?
I didn't want to say 2.
That's okay. So right now, after combining all the like terms, that ends up becoming your answer. Okay. All right, here we go. We're going to get 2 more problems done before this class ends. Here's the first one, okay? We have 3.7x. We have plus a half minus 6y plus 0.8. Now this is where it gets tricky. Does everybody see where this negative sign is? It's on the outside of the parentheses, which means you have to distribute that negative to every single number. So when you distribute that negative, now you have a negative 1.7x. You have a negative 1, and you have a positive 2.3y. Because a negative times a negative is a positive. Now, I'm going to highlight everything that's alike. Scanning for x is scanning for okay. We have a half, 0.8, negative 1. And last but not least, we have a negative 6y and a 2.3y. Now you have a calculator, so what can you guys do in the calculator? Just type in the decimals. Alright? What is 3.7 minus 1.7? That becomes just what? A 2, right? So that's 2x. What is a half plus 0.8? That's 1.3. What's 1.3 minus 1? It's just going to be what? Plus what? 0.3. 3/10. Okay? And we have negative 6y plus 2.3. What does that become? Negative 3.7y. So we're looking right now. Here's what we're looking for. We're looking for an answer that has what? 2 x's. We're looking for an answer that has negative 3.7y. And finally, what constant do we have at the end? 0.3. And my board's just like you. My board is starting to be. Alright, so let's look through here. Yep. Answer choice C. It has that, it has that, and it has that. So what was the tricky part of this one? What's the only thing that makes this kind of hard? distributing a negative. Whenever you guys see a negative on the outside of parentheses. Notice, did I worry about this one over here? Yeah, so nothing's going to change. So everything inside the parentheses, everything here, what happens? It all stays the same. What happens inside here? They all become the opposite. Now what does that mean when I say it becomes the opposite? If it's positive, it becomes negative. If it's negative, it becomes positive. That's what negative signs do. They make everything the opposite of what it is. Okay? Alright. Let's go ahead right now and look at number 5. This is an inequality. You're going to see some inequalities on the test. We might as well get one done before you guys leave today. 3 parentheses 2x minus 1 close parentheses is less than 2 open 4 plus 3x. What are we going to do at the very, 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 very beginning? Distribute. And distribute. So we get 6x minus 3 is less. Distribute. 8 plus 6x. Uh-oh. Here's the inequality sign. If I take away 6x from this side, and I take away 6x from this side, that zeroes out, that zeroes out. All the x's have disappeared. Oh no! Well, ask yourself this question. Is negative 3 less than 8? And this is true. If all the x's cancel out and it's true, the answer is all real numbers. If all the x's cancel out and it's not true, then the answer is a null set or an empty set where there is no answer. Okay? So, if you guys, sometimes the answer is going to be C, sometimes it's going to be D. If all the variables cancel out. Alright? So this one right here, everybody, all the x's canceled out, so the answer was all real numbers.
So x is all real numbers.
Right. X is an element of the real number system. Yeah, that's what it means. X is an element. That means null set, empty set, there's no answer. No answer. Okay? Alright, so so right now the answer is this. Okay? Why? Because negative 3 is less than 8. But if my symbol would have been the other way around, is negative 3 greater than 8? No. Then the answer is no real numbers, or is your empty set. Okay? So if all the x's cancel out, and you have a true statement, if it's true, this is your answer. If you get a false statement, what's a false statement? 2 is greater than 5. If all the x's canceled out, then you would say, uh-oh, 2 is not greater than 5. The answer is false. It's no real numbers. Alright, so right now, last thing we're going to do, we're going to go ahead and quickly solve this. 47 minus 12x is less than or equal to negative 48 minus 12x. That's if you distribute that to both numbers. Okay? So right now I'm going to add 12x to this side. I'm going to add 12x to this side. This zeroes out. We have 47 is less than or equal to negative 48. Is 47 less than or equal to negative 48? No, that is a false statement. That's totally false. If it's false, H. Okay? So, oh yeah, if you forgot the negative, then you would have gotten the other answer. Okay? Alright, right now, if everybody would please, I'm going to be doing one more problem, and it's going to be problem number 8. Everybody, here we go. This will be your final one. We did number 7 already. B equals, I'm going to put this right here, this mu with a little subset O times I over 2 times pi times R. This is a formula, okay? It's a formula for determining the magnetic field around a straight conductor. That's this formula. Notice, what are all these answers in terms of? R. So right now, everybody, I'm just going to show you guys how to solve for R. That's it. So right now, all I'm going to do is put this over 1. So B over 1 equals all of this. We're going to cross multiply to go ahead and start out. We're going to cross multiply. What is all of this times 1? Itself. So here's what we have. We have B We have a 2, we have a pi, and we have an r, and that's equal to m subset O times I. We only have one step to solve for r. You're going to divide everything by 2, you're going to divide everything by b, and you're going to divide everything by pi. So your final answer is the radius. The r value is equal to MOI over 2b pi. So which one is MOI over 2b pi? You got it? I know, that's why I'm recording it. I know, it moves fast because. By the way, what's this problem like though? This problem is like what problem? All the problems we did today at the very beginning of class. All these 14, 13, 11, solving for a specific variable. That's what that problem is like. Y'all have a good day. Study up. Make sure whatever you guys write in your journal you can use.